we are going to do the derivative of e to the x, a to the x, ln of x, and log base a of x. Where's your notes? I'll tell you, the focus of the exam is on e to the x and ln of x. So we have to do very well with this. No, e to the x is e to the x. That's an exponential. Ln is a log function. Oh, we got this one. There it is. Just want to see what the show is. I think there's a typo on here. Okay. This must be an old slide. But let's find the derivative of e to the x. The relationship between exponential and log functions provides a powerful differentiation tool called logarithmic differentiation. And it's a skill that will help us do weird things that aren't exponentials or powers. Okay, we'd like to find the derivative of e to the x. And we're going to use the definition. It's right here. It doesn't look quite the same. It says we'd like to... I don't have all the beginning stuff on yours. I don't know why. That's... Well, okay, let's see if I can slide this. Oh, good. It's not all... It's a yellow one. Right. So what does e to the x look like? Now, we need to know this. It's an exponential function. What is e? Yeah, it's just a number. It's 2.7 approximately. So it looks like 2 to the x, 3 to the x. They all look the same. So here's e to the x. They all go through this point. Where's that? 0, 1. Now, if you want to try to sketch the derivative of that, kind of nice to see that. The slope here is not quite 0, but it's pretty close to 0. Slope here looks like it's probably 1. And what's true? The slope's getting bigger. And if you put it on your graphing calculator and you graph it, you will see that the derivative of e to the x is e to the x. That's the only one that's like that. The derivative with respect to x of e to the x is itself back again, like a phoenix rising out of the ashes. That's right. He stole that. That's an old thing. Okay, so let's use the definition of a derivative. I would think you'd want to see why it is what it is. So, or you could just believe me, but I could be lying. Do you remember the definition of a derivative?
Oh, I know it.
What is it?
F of c plus h.
That's right.
Minus f of c.
Okay.
All over.
All over h. It's just the slope of the tangent line. At any particular point, you're going to drag these points closer and closer together. So let's go ahead and substitute this in here. And so it's the limit as h goes to 0. And in place of x, I'm going to put in x plus h. So it's e to the x plus h minus, and then in place of x, I'll put x, e to the x all over h. And you're going to say, I don't know an algebraic trick to figure that out. And you're right. I don't either. But I can do a little bit of work. And in BC Calc, we have to do a lot of stuff with exponents. Can you rewrite e to the x plus h a little differently? The rules of exponents, so I can write that as e to the x times e to the h. Do you remember that? I'm going backwards. So if you have x to the m times x to the n, what do you do with the exponents? Add them. So if I want to go that direction, it'll be the product of those x's to the m and the n's. Can I factor anything out of that? I can take out an e to the x. So it's the limit as h goes to 0, and then I'm going to need my graphing calculator. It's e to the x times e to the h minus 1 all over h. Now, this limit only works on h. Does it affect e to the x? No, you can actually pull that out of there. And slide this down. And so that is, I'm going to pull this right out in front. And then we're going to use our graphing calculator to look at this limit. So it's e to the x times the limit as h goes to 0 of e to the h minus 1 over h. If you put in 0, you get 1 minus 1 over 0. So it's going to take me a second. Oh, wait. Try and pull this up. Let's see. There it is. Did I not get it? There it comes. So I'd like to look at that limit. Now, these are dummy variables. So I don't care if it's e to the h minus 1 over h or if it's e to the x minus 1 over x. It doesn't make any difference. So we're going to clear this out. And by the way, you can do these really crazy summation things that I have up here. It's kind of cool. We do that in BC. Yeah, those are factorials. Okay, I don't want that. Okay, so I'm going to do e to the h minus 1 over h. But I don't want h, I want x, because it's just easier. I'm going to have to put a parenthesis here. It's not going to work. And e to the x is this log button. I'm going to put in an x. And then I have to go back down, so it's minus 1 divided by x. And I'm just going to zoom it decimal. What does it look like the value? Let's turn the axes off. Let's see if we can see a hole there. So you remember, do you know how to do that? So if I go to second format, and I turn my axes off. And that I should be able to see the hole, but I'm not positive. Should be just a little bit of a tiny break there. Yeah, it's a tiny break there. So what's the limit getting close to? What are the wise values getting close to? Yeah, so if I do a trace, x equals 0, it says nothing exists. What do you think it's getting close to? Look at the y values. And so if I go second table set, and I want to look at that, let's start at 0. Let's make my change in my table really small. Well, not too small. 0.001 is close enough. And if I look at my table, it can be even more obvious. So it looks like it's getting close to 1. So I can take this picture and I can put it over here. So that this limit is actually 1. I don't think you have to know that on the exam. Not without a graphing calculator. So there it is. What's still left here? E to the x. So the derivative with respect to x of e to the x is e to the x. So you know they're not going to just give you e to the x, because that's boring, because it's just e to the x. They're going to give you e to some function of x, is what they're going to do. Right? And we're going to have to do the chain rule. And that's on my next slide. I don't know why it's not on this one. There you go. Yes. Kind of a cool little proof. Don't expect you to know it, but it's kind of nice to see it, why it is e to the x. Okay, we ready? We're going to have a bunch of these. And so, oh, I have that connected. Sorry. What if I do the chain rule? What if y is equal to e to the f of x? Then y prime, I'll rewrite it, is e to the f of x back again times the derivative, and it doesn't look like an inside function, but it is. It's the derivative of that exponent. And I would tell you that they're almost all exponential or logarithmic functions on the exam. So when the students came out of the exam last year, they were kind of freaked out a little bit because of that. So we're trying to warn you now. So let me write this one. So y equals e to the x plus x squared. So I want to find the derivative of that. I want to find y prime. So what's y prime? On page 2. I don't know why I have this split like that, but I do. I got typos on the next page. I see what's encompassed. So it's what you have here back again. That doesn't change. X plus x squared times 2x plus 1. That's it. I fixed that yesterday. Take a piece of paper, fold it, put it underneath the light. I fixed it yesterday, but the paper's gone. Okay. That's all there is. So e to the x isn't bad. Are you ready? No. Okay. What about, now you have to recognize the difference here. And it's hard for a lot of students. A to the x is an exponential. An example of that would be 3 to the x. But x to the a, if I switch these position, is a power. For instance, if I switch these, this is x cubed. They have very different graphs. 3 to the x is going to look like this. And x cubed, especially if I have middle terms, are going to look something like this. This is a polynomial, and they behave differently. Their derivatives are different. You can't use the power rule with an exponential. You'd like to, but you can't. Some of you will still try. So we're going to try and figure out how to find the derivative of a to the x. And I have actually some major typos on the next piece. I didn't even fix it. I thought I fixed it here, but I didn't even fix it here. It should be, can I move this? No. Okay. Let's work here. First off, I have I don't know what I have, x to the ln of x on your sheet. Let's cross all of that out because it's wrong. That should be e to the ln of x. Remember, exponentials and logs are opposites. Yeah, very middle of the page, method 1. So just cross out that whole top line, remember, because the whole thing is wrong. Well, no, I want this. What's this? No, it says x to the ln of x. I know, but there's more. The whole thing's wrong. I'll show you. What's e to the ln of x? I should fix it before I forget. That's just x. So what's e to the ln of some function? It's just this function. Remember, these are inverse operations. So, and I know it's hard to do, but we're going to rewrite a to the x as e to the ln of something. So we're just going to ignore all my typing on there, so it's not right. Well, that's not that big a deal. I mean, have you ever tried this? Have you done e to the ln of 9? What's that supposed to be? Yeah. But when I look at it, I don't feel comfortable. I don't feel like that's intuitive, like that's something that should happen. Do you? No. I even went and put it on my calculator. Sure enough, it's 9. It's not even 8.999. It's 9 on my calculator. Okay. So are you okay with using a's, or do you want me to use like a number like 2? Okay. So let's do y equals 2 to the x. Okay, let's write it in terms of a logarithm. This can be written as e to the ln of this function, 2 to the x. I know it doesn't feel like that's 2 to the x, but it is. Then I'll show you a different way to do it. Okay, which I don't like this way, but it's okay. They're the same things. They don't feel like they're the same things. And then what can I do? Do you remember your properties of logs? Do you remember ln of x to the r? It's r times the natural log of x. You bring the exponent down the front. So this is, I can change how this looks. You're going to want to use your properties of logs. It will make the problems easier. This is e to the x times the natural log of 2. Is that okay? You can bring this little exponent down in front. Now remember, log of 2 is just a number. Right? Log of 2 is just a number. It's 0.69 something. I don't know what it is exactly. That's a number. Let's take the derivative of this. So what's y prime? It's almost y prime. It's this whole thing back again. So it's e to the x times the log of 2 times the derivative with respect to x of x times the log of 2. Keep in mind, the log of 2 is just a number. It's a constant, right? I don't want to go too fast, so you gotta see this. Well, you don't really have to if you could just memorize it. So y prime is equal to e to the x times the log of 2, which we can replace that in a second. What's the derivative of this? Remember, this is not a product rule, it's a number. So if I have 0.6x, what's the derivative of 0.6x? It's 0.6. So this is times what? A log of 2. It's 0.69 something. I just rounded it. That's all it is. You can put it on your calculator. It's just some number. It's 0.691 something. I don't know exactly. I just got familiar with it. Okay, but what is e to the x log 2? It's all the way, we work backwards. It's this, right? Which was this, which is that. You might like the other method better. So this is equal to, y prime is 2 to the x times the log of 2. So it's just like exponential function. So let's apply this. If I have y equals to e to the x, then the derivative of this is e to the x times the log of the base. What is log? What's the natural log of e? 1. That's why we don't write it. So it's exactly the same thing. So what if y equals 3 to the x? Y prime is the same thing back again, times the natural log of the base, which is natural log of 3. These match. This is what you have to memorize. You're not going to go through that process. You have to recognize it. They're both right. All right. This one? It's because this is equal to this. I just worked backwards. I could have gone back and shown you. I could have worked the steps out. But this looks like x log 2, but that's the same as e to the log of 2 to the x. And e to the log of 2 to the x is 2 to the x. Remember how we worked down? I don't like this method as well as the other method. I think you'll like the other one better. So what is it in general? What if it's a to the x? What's y prime? A to the x times the natural log of a. So if it's e, it's times the natural log of e. So if you want to be consistent and put log of e in there, you may. But we know that the natural log of e is, we remember this one, right? 1. What's the natural log of 1? Anybody remember that one? 0. While we're here doing properties, what's the log of a times b? It's the log of a plus the log of b. What's the log of a divided by b? Yeah, log of a minus the log of b. I can think of an AP problem right away. It's so much easier to do the derivative. I don't want to do the derivative of this. I'd rather do the derivative of the subtraction problem. Easier. No, all you're going to do is write it down. So do I have an example here? If not, I'll find one. I'll make one up. Let's just make one up. Do I have one? Yeah, we already did all that. Yeah, we did all that. So, what if I have y equal to 5 to the, we're going to do 5 to the sine of x. Oh, no, I don't want to do a composite function, do I? Sure I do. What would you do with a composite function? So what if I have y equal a to the f of x? What do you think the derivative would look like? A to the f of x times the log of the base, and then we do the chain rule, times what? What do I think the derivative? F of x, right? Now I can remember this myself because my first name is Lena. There's Lena, L-N-A, without the little a in between. But that'll help you remember it. It's a to the x times Lena, L, and that's the log of a. Can't help it, but I keep thinking that. It's kind of weird. So if I have y equal to 5 to the x squared, let's do a simple one. Then y prime is 5 to the x squared. Remember, this is an exponential function, times the natural log of 5, times what? 2x. There's a method 2. To show you that is what it is, which is on my next page. Not on my next slide, if I look at my slide. Okay, well, okay, here it is. Now you want to use numbers, right? So y equals 2 to the x. Okay, so I don't want to do that e stuff. That's too confusing. Can we solve for x? What's x equal to? All I have to do is log both sides, right? Oh, wait. I can't do this yet. I have to wait. I have to do the one before it. I knew I had to do something here. I do have to do this one. Sorry. We don't have the derivative of the natural log yet. I do have to do this. It's missing on yours, though.
Oh, no, it's down.
Oh, okay. It should be before method 2. Okay. So y equals the log of x. What's x equal to? Now, Ms. Hersman exponentiates each side. I do the whirly thing. But you can do this, because this is e to the log of x is just x, right? And so this is e to the y. So now, let's take the derivative of both sides. This is implicit differentiation again. You're just going to memorize what the derivative is. But in case you get stuck, kind of nice to know where it comes from. What's the derivative of x? 1. So then it's e to the y times the derivative of y with respect to x. Solving for dy dx is equal to 1 over e to the y. Is that okay? But I know what y is. What's y? The log of x. So it's 1 over e to the log of x. But I can simplify that. What does that simplify to give me? 1 over x. I solve for dy dx here. Remember, I have to do the chain rule. It's e to the y times the derivative of the inside function. I know it doesn't look like it's inside, but it's e of that thing. It is inside. So this ends up being 1 over x. So here's another derivative. The derivative with respect to x of the log of x is 1 over x. Could write them up on the board. So you want to see where we're at right now? We have this. The derivative of e to the x is e to the x. What's the derivative of a to the x? Any other number than e. A to the x times the natural log of a. And the derivative with respect to x of the natural log of x is 1 over x. You're going to have to memorize these. They're probably up here someplace too. They are an integral. Now we can do method 2. Are you ready? Whoops, okay. Sorry. These are just the derivatives. I'm going to use method 2 to show you why, another way to show you why this is what it is. But I needed to have the log function to do it. You'll see in a second. Because it was 1, when you solve dy dx, it was 1 over e to the y, and y is the natural log of x. And we remember e to the natural log of x is just x. I have to constantly remind myself of that. Okay, and we only have one more derivative to do, and it's any other base log. Any other base log, how do we do those? And that's when things get a little confusing. Not too often do you see it. You're going to see natural log. So natural log is better. Okay, I'm going to start this over again. So let's take just y equals 2 to the x, and let's rewrite this. Let's take the natural log of both sides. Do any base you want, but I don't know the derivative of any other base at this point. So the log of y is equal to the log of 2 to the x. What can I do with that x? Bring it down. Okay. Now let's take the derivative. We're going to do it implicitly. It's okay. That's why we do the implicit differentiation. It gets us around a lot of problems. Now, what's the derivative of the log of y? What's the derivative of the log of x? 1 over x. What's the derivative of the log of y? 1 over y. Then you have to do times the derivative of the inside function, called y prime. And we did this one. Remember, the log of 2 is just some number. What's the derivative of a number times x? It's just the number, so it's the log of 2. Solving for y prime, I'm going to multiply both sides by y. I think this one makes more sense to me, at least. So y prime, this is method 2, is equal to y times the log of 2. What was y? Y was equal to what? 2 to the x, right? So this is 2 to the x times the log of 2. Doesn't matter. I just want you to get the feel for it. I like it much better. But I had to know the derivative of the log to do it. Have to do it implicitly. So there's motivation for knowing the implicit stuff. Yeah. Oh, we're doing really well on time. We have one more derivative to do, and then we're done with derivatives. Sam. Then we're going to reverse them. Sam, what? Of y. It's the natural log of y with respect to x. The derivative with respect to y of the natural log of y is 1 over y. Prime? Because then you have to do the derivative of the inside function, because this is an x, not a y. Okay. The other base logs are not bad. I never memorized the formula. I have no idea what it is. And if you'd like me to use numbers, we're going to do a change of base. Matter of fact, let's make it base 2 or something, not 10. Now, your calculators, if you have the new operating system, will do a change of base for you, which is kind of nice. But you remember the change of base form, the log. It's going to be the log. I want to go to natural log. So it's the natural log of the argument, which is x, divided by the natural log of the base. That's the change of base. Remember that?
Yeah.
I do it, so I have to memorize the other derivative, because I never remember it. Now I can do a derivative, but let me rewrite this. This is 1 divided by the natural log of 2, but that's just a number, times the natural log of x. Do you agree that these are the same things? But it could be base 10. No, I want natural log, because I don't know what the derivative of base 10 log is. All I know is the derivative of the natural log of x, because that came from e to the x. That was 1 over x.
Why are you allowed?
That's just a change of base formula. So if I have log base a of x, I can change it to log of x base b over log of the base there, a, and change that to base b. I want to use natural log. I could take any log I'd like, because this is the change of base formula. I can show you why the change of base formula works, if you'd like, because I've never knew change of base. I would rewrite this, 2 to the y equals x. That's how I used to do it, how I was taught a long time ago. We have 2 to the y is equal to x, and I want to change that to natural log, then I'll natural log it. And this becomes y times the natural log of 2 equals the natural log of x. So y is equal to the natural log of x divided by the natural log of 2. That's what I do. I rewrite it as an exponential, and then I natural log both sides. Or you memorize the change of base formula. I've memorized it now, so it's like I become acquainted with it. Okay, so let's take the derivative of this. So what's y prime? Can I ignore this? It's 1 divided by 0.69. I have no idea what it is. 5/3. I don't know, whatever it is. 1 over the log of 2. And what's the derivative of the log of x? 1 over x. Remember what y was? Y was equal to log base 2 of x. Honestly, I do the change of base and then do the derivative. I don't memorize this formula. I'm going to come up with it in a second.
So, what was your, like,
Because I want you to see that this is a constant, just a number. You'll try to use the quotient property, quotient derivative. I don't want to do that. I can. I'll get the same thing. So look what it is. The derivative is 1 over the natural log of this base times 1 over x. So let's do another, just a plain one.
So it's always 1 over.
Yep, I'm going to.
log.
So what if y is equal to log base 10 of x? What is its derivative then? Y prime is equal to 1 over the natural log of this number, that's the formula, times 1 over x. Personally, I would change this. I would say that's really y equals the natural log of x divided by the natural log of 10. And then when I take the derivative, I leave the natural log of 10 just by itself, it's just a number, times the derivative of this, which is 1 over x. So what if it's log base a of x? Then what's the derivative going to be if you want to memorize it? It's 1 over the natural log of a times 1 over x. So it looks a little different than a to the x. The natural log of a is in the denominator. And I get confused as to where it goes. I want to memorize. So that's what I do. But if natural log is base e. So if I had y equals log base 3 of x squared minus x. What about that one? So y prime, do the easy part first. It's 1 over the natural log of the 3. If it was natural log, it's natural log of e, which is just what? Natural log of e is 1 times 1 over the x. What's x though? It's not x. This is f of x here. So it's 1 over x squared minus x, then chain rule times the derivative of the inside one, which is 2x minus 1. And we can look at some homework problems. So that's it. Should I go back to the slide where I have them all? So we can add it in there? Where is it? It's at the bottom. There it is. So the last one here is the derivative with respect to x of any other base. So it's 1 over the natural log of that base, which is a. So this is times 1 over the log of e. So I get the same pattern. Times 1 over x. Sasha? Yes. Can you rewrite it as x ln of a? Yeah, it's probably the way it's written in the book. It's the same thing. Oh, 1 over the log of e. But remember, what's the log? And this is times the log of e. Now these look alike, don't they? It's the log of the base. But what is the log of e, natural log of e? 1. So we don't write it, but at least it's consistent. Just so you can see that e to the x is e to the x log e, a to the x is a to the x log a. Just to see the patterns. It's the same thing. But we don't write that because it's just 1. Don't have to. Okay, I think we should do some problems. Either out of the homework, I haven't looked at the homework. This isn't as bad as the secant stuff. Oh, let's do example 4. Last page. And then we can do some other things. Make sure you simplify anything with logarithms if you can. Where is it? Oh, we'll just put it at the top of this page. Oh, magic. Now, this is what I mean by simplifying, because this is an easy problem if you recognize something. I didn't write this property. What is that? Y equals the sine of x. Because if you have log base a of f of x, That's the same as e to the ln of f of x. And they like to do that to you on the exam. They like to throw things at you and make it really hard. You're going to look at that and go, I don't know what to do with it. Well, simplify it if you can. So what's y prime? Yeah. Yeah. That's it. By the way, does it make sense that the derivative of the natural log of x is 1 over x? Let's look at the graph. I think we probably have to ignore those. I don't know what's been assigned. What does y equal the natural log of x look like? We have to know this. Yes, it looks like this, and it goes forever. It doesn't grow very fast. Remember, that's the inverse of e to the x. This is at 1, 0. Your calculator tends to lie. It goes to negative infinity. It never gets to the 0. And look at the derivative. What's true about the derivative of this function? This is pretty darn steep, right? Looks like positive infinity, which means it's up here. And then it starts getting smaller and smaller and eventually goes to pretty close to 0. So it looks like this. What's that graph? Y equals 1 over x. That makes sense? These are always positive. So this graph is always going to be positive when it starts leveling out. What's the domain? X is greater than 0. I don't get that left branch. Now I can think of an AP problem off the top of my head. I can do it right here. Yes, but you know what? I don't know where they are. Because this is algebraic and that's logarithmic. I'd have to do it on my graphing calculator if I know where it is. It's not 1. Maybe, no, it's not E. This is the domain. Okay, so this is the problem I saw. Something like this. And you were to find the derivative of that. Well, if you blindly go into it, you go y prime is equal to 1 over that thing times the derivative of that thing, which means I have to use the quotient rule. Or I could be clever. Can you rewrite this differently? You can rewrite that as y equals the log of x minus, whoops, got the minus, minus the log of x minus 1. Now find the derivative. Tell me, is this easier or harder? This is easy. Y prime is 1 over x minus 1 over x minus 1. That's it. If you do this and the quotient rule and you simplify all those complex fractions, you will get that. I'd rather do this. We took this and rewrote this like this, using properties of logs. That would be the derivative if I'm blind and I don't see that I could change that. And you can get it. You had to evaluate it at something like 2. It wasn't terribly difficult. But remember, you're on a time test, so if you can see some of these things fast, it will save you a lot of time. It's not exactly the problem, but I remember it's pretty close. Just don't forget to check the products rule. So I don't know if you want to look at any of the homework problems, or if you still have questions on homework problems from yesterday, just skip the ones that say secant. Because we're not going to, even in those college prep ones or whatever, we're not going to do the derivative of the secant. So 3/9. Let's see how bad this is. Well, this looks pretty straightforward. So if you look at 17, there's an easy way to do that. So 3.9, I don't know if you have homework questions, otherwise you have time to work. Number 17, we can do them together, or you can just work on them. We can do number 1, is y equals the log of 1 over x. I want to use properties of log before I do anything. Because what's that equal to? Log of 1 minus the log of x. What's the log of 1? 0. You want me to put the properties back up here? I can't. So y equals negative log of x. So what's y prime? Negative times 1 over x. If you try to do it with the quotient rule and everything and simplify it, you'll get there. So if I have the log of 1/2, that's equal to the log of 1 minus the log of 2. I don't know if you ever realized this. The log of 1/2 is equal to 0 minus the log of 2. So the log of 1/2 is the same as the log of 2, but it's negative. Well, the log of 1/3 is the same as the log of 3, but it's negative. If you never saw that. Yeah. There you go.
Yeah.
Another one. So do you want me to summarize your log properties, or do you think you have them? Isn't that cool? When you see something like that, it's very cool. Okay. Actually, if you go back to your notes, you should have, let's see. Log base A of A is x. Log, whoops, not lag. Log base A of 1. Sorry, that's 1. That's 0. Log base A of x to the r is equal to r times log base A of x. I'd rather use natural logs. It's just easier, but whatever. Log base A of, well, I'm not even going to do that. I'm just going to do regular log because I'm too confused. Of A times B is the log of A plus the log of B. The log of A divided by B can't do anything with it. We get tempted. I get tempted too, but unfortunately, you can't do it. I think that's the basic ones I'm thinking, and also we have e to the ln of x is equal to x. E to the ln of f of x is equal to f of x. Somehow you can combine them. Do you have homework questions, or do you just want to work? Did you still have about 15 minutes? So actually get started on this, or work on what you didn't finish on 3-8. Good. Was it that bad? No, it shouldn't have been too bad. That was the hard one. That's the hard lesson. Remember, it's like a roller coaster. Some things are going to be easier than others. And I also, at the bottom of this page, why don't I just put my derivatives here. You will get a sheet with derivatives that you'll want to fill out. So the derivative of e to the f of x is e to the f of x times f prime of x. Maybe we'll get that tomorrow, I'm hoping. The derivative with respect to x of a to some function is a to that function times the natural log of a times f prime of x. The derivative with respect to x of the natural log of f of x is 1 over f of x, well, times f prime of x. Almost forgot my chain rule. And the derivative of any base log is 1 over f of x times 1 over the natural log of whatever the base is, b, times the derivative. And that finishes up all of your derivatives that we have to know in this class. Yeah, you might want it written down. And I save it. I put it up on the Schoology. All you need to do is download the student version of the software for Smartboard. It's easy. It's free. It doesn't take up much space at all. Pardon? No. Well, I don't know. I never ran into them, but I have a Mac. No. Test is everything in Chapter 3 because you have the product rule. There's no way to separate it out. You're gonna see the product rule with e to the x. I'd rather let you work on homework. So you should be okay with these because they're just, I don't understand what they mean you can use n derived to help you with the computations because you can't. You can if you have a cast. And then that's it. I would definitely do like the quick quiz for AP preparation. Those are very typical AP kind of problems.